This conference will now be recorded.
Fine. In last sessions, we just went through the detailed concept of what is data warehouse, who needs it, what is the purpose of data warehouse, what are the basic difference between OLTP and OLAP system. All right. Can any one of you tell what is data warehouse in on a nutshell? What is data warehouse?
Data where Srikanth, if you want, you can proceed.
No issues. Go ahead.
Yeah, it's a warehouse. Warehouse is that is a place where we are where we maintain the history and which is having a collection of data marts.
Right. So it's actually a centralized database which collects data from different data sources. We do some transformations on that data and we load the required data which is useful to generate a report in a visualization format that can be used for the business users to enhance to take some effective decisions at on the business. Okay. And it is mainly used to maintain history of information, right, where you can do whatever analysis you want, you can able to do on it based on the data stored in it. The storage of data, in what way it needs to be stored, that depends on the requirement, whether you need to maintain history or whether you need to maintain a partial history or you want to maintain only the latest details. So this will categorize a project how to maintain a data. Right. So what is OLTP system?
OLTP, where we can store the raw data. It is the raw data.
OLTP is online transactional processing, which holds the raw data. It is basically a source system where we will have a lot of detailed informations, and we may need to retrieve the data whichever is required from the different source systems, right? And what is OLAP system? OLAP,
Well,
OLAP.
OLAP is analytical process. Right?
Yes.
That is transactional processing, which is having a current data. Like as you said, it maintains in supermarkets and all that. This is for the analyzation data used for the report purpose.
Right, analytical data, right, which will allow you to do a certain analysis on the data what you hold. So analytical, it is nothing but a target system, or it's also a data warehouse system. Yeah, so this
Exactly.
is about the basic terms which we use in warehouse. And now moving further, there are certain very important terms that we use throughout your data warehousing, which are nothing but dimensions, facts, dimension tables, fact tables, and types of facts. That's These are the things that is into the next category where we will see in term of a concepts. Okay. So when I talk about a dimension, before going into a dimension or a fact, what does a table contain?
Rows and columns.
Rows and columns, right? So now I'll just take an example of an Excel. Okay. Now assume I have customer ID. Customer age. Name. Product ID, product price. have these many columns in my table. Okay. For example, I have customer ID 1001. His name is Smith. His age is some 45. Product ID is 001. Product price is 500. Out of 500, the profit which was gained is some 80 rupees. 1002 meter 32. I have these two records as a sample. Now, this customer ID, customer name, cust age, product ID, product price, profit. These are nothing but columns in a table. And these two are the records in a table. Right. So these are rows and columns. It's nothing but a combination of a table which forms a table. Now, when I say dimension are nothing but a column. But there are two terms in data warehousing which are very important. One is dimension and other is a fact. So out of these columns, which are termed as a dimension and which is called as a fact, that we should be in a position to categorize it. So how we can categorize it, right? We do have a certain, like if you say a dimension is a collection of reference or descriptive information about a measurable event. About a measurable event. We'll see what is measurable event later. A dimension is a structure that categorizes facts and measures in order to enable end users to answer the business queries. Example, product, time, order. That is, a dimension is nothing but a column which will help you to analyze the fact. So before completing the dimension or understanding the dimension, we will just see what is a fact. A fact is nothing but a numeric value which have impact on business. When I say fact is a numeric value, which means fact cannot be a character value. It should be always numeric value. A fact is a quantitative piece of information which is stored in fact table and have a foreign key relationship with a number of dimension tables in it. This we'll see it later. So what is a fact as of now? Fact is a numeric value. Fact is a numeric value which have impact on business. You cannot say all numerics are facts. For example, I have order number. Order number 001, 002, some values I have. Though it is having a numeric value, it cannot become a fact because the order number doesn't have impact on the business. When I say having impact on the business, it means the value which gets changes and which has high priority in it. Suppose I have some calculation amount, like what is the current balance. So that determines the balance amount which changes again often and it has an impact on that particular business. If I am saying a profit, for example, the sheet here, I have a customer ID. Whether customer ID value is numeric or not, according to this sheet, yes, it is numeric value.
Yes.
But it will not have impact on the business because this value is always static. Each customer will have an ID and that ID doesn't determine anything in terms of a business. It will not change. It is constant value. I have a customer age. Yes, of course, the age is also a numeric, but it also changes. But does it have impact on business or it have impact on that particular customer? This is age of this particular customer and it doesn't relate to the business, right? It is not impacting business. It is just impacting this particular customer. I have a product ID. Product ID is also a numeric value, but it is a constant value which doesn't change. It doesn't have impact on the business. When I say profit, see here, how much profit generated by this customer when he is purchasing a product 1. Yes, there is an impact, right? This is also a numeric value, but it has an impact, that is the value whichever you can able to measure. The measurable objects are nothing but the fact. Can you able to measure customer ID? See, measure in the sense I have 1 liter of water in a bottle. You can able to
You
measure.
can't.
I have 5 liter of water. Yes, that is a measurable object. What is the profit generated by this particular product? 80 rupees, 2,000, 300. You can able to measure, right? Anything which you can able to measure and that is a numeric value is nothing but it is a fact. Facts are numerics which can be measured. What is the loss of that particular percentage of loss of this particular product? Loss, yes, you can able to measure. How much quantity
Yes.
sold, how much quantity sold for a particular product in this particular region. Here, which is
Okay.
fact. Quantity is fact. How much quantity? So anything which you can able to measure or facts. That will obviously have impact on the business. So facts or numerics which can be measured. Facts or numerics which have an impact on business. Fact is a quantitative piece of information which is stored in fact table. When I say fact, when I say dimension, dimensions are stored in dimension table and facts are stored in a fact table. We will see how it is stored in further session. Right now it is just a fact, it is stored in a fact table that will have foreign key relationship with the dimension table. That is, when you have multiple tables in a relational database, how those table will be interrelated. We need to join, which we should have some interrelationship between those tables in the form of a foreign keys and a
But
primary keys, right? Primary
yes.
key and foreign key will is actually treated as a child table, whereas a primary key table is a parent table. Foreign key table will refer to the primary key table. So this is how the relationship will be. For example, see, there are some examples which I have listed here for fact: sales, profit, discount, quantity. What is a discount provided for this particular product? You can able to measure. There is a separate term, again it is a measure. Measure is nothing but an aggregation of a fact or dimension. Sum of sales, max of product, count of customer. Right? We see all this with an example in further sessions. So fact, you know now what is a fact. Then what is dimension? A dimension is a collection of reference or descriptive information about a measurable event. Is if you want to analyze a fact, you need dimension. Okay, if you want to if I want to analyze, say I'm just saying profit 20%. What do you understand from that profit 20%? I'm just
You
simply
mean
saying profit is 20%. Immediately what runs in your mind? Profit is 20%.
you mean
Profit of
is it
what? Yeah, go ahead.
profit of product, right?
Yeah, so profit of something. So what? Profit of what? Profit of some product or profit generated by this particular store or profit generated by this particular agent or customer. So these are all some of the dimensions based on which you can analyze the fact. So without
Right.
dimension, we cannot measure the product. Clear? So when a column is called as dimension, and when it is called as a fact, you should be in a position to understand it. Right? I have, see now here, I have a profit. Profit is a measurable object and it is a numeric, hence it is a fact. Profit of what? Profit of the product 1 and 2 listed here. Profit generated by whom? By the customer 001 and 002. 1001 and 100. So the facts or numerics which is used to analyze based on the dimensions. Can you able to understand? Without dimension, you cannot analyze the fact. Dimensions will hold the descriptive values in it. When I say descriptive values, dimension will have its underlying details. Like I have a customer dimension. So under customer, what are all the customer related detailed informations will come? Customer ID, customer name, customer customer age. So these are all some of the descriptive values of the customer. Clear? When I have a
Yeah.
product as a dimension, product ID, product name, product unit price, product code, product color, product description, the fields related to product are nothing but a descriptive value of a product dimension. So what comes under time dimension? Can you just think out what can be splitted out under time dimension?
Time
Time.
like a date will be
Exactly.
there,
So
and
right.
minutes will
So
be
when you
there,
say
year will
time,
be there.
exactly. So year wise, year, yearly, quarterly, monthly, day, weekly, date, all these comes under time dimension. So dimensions are nothing but it will have a collection of descriptive informations which are used to analyze the fact. Srikanth, can you able to
Okay.
follow? Yeah.
Yes, ma'am.
Okay. So please stop me. I am here to repeat it again if you couldn't follow.
Okay.
So there are two terms very important now at this point. It is dimension and a fact. Facts are numerics which can be measured. Dimensions are used to analyze the facts, and dimensions will have the descriptive value. When I say region dimension, under region, what are all the descriptive values that comes under a region? Region is a dimension or fact?
Dimension.
Region is nothing but it will have location,
This
a geographical representation. Yeah,
it's a dimension.
it's a dimension. Region is a dimension where you will have country, state, city, and whatever underlying object of it. Okay, so facts and dimensions. A numeric can be a dimension or a fact. When it is fact, when it has a business impact, then it is called as a fact. If it doesn't have impact on a business, then it is called as a dimension. You cannot say all numerics are facts. The numerics which have impact on the business are called as a fact. When it will have a business impact? Only if it can be measured. Clear? Is it clear?
Yes.
We'll see a general term of primary key, foreign key, surrogate key. You might be already aware of it. It's just a brush up because we will be using all these terms in further sessions. Okay. So what is a primary key in general? Primary key. What's a primary key? Srikanth, Srinivas, any one of you? Very, very basic. Just give a basic definition. I'm not
It
expecting you more.
a primary key, and no, I didn't know that you were asking. The primary key is a unique key in a table.
Exactly. So primary key. If I have multiple records in a table, and if I want to uniquely identify a record row in a table, then there comes into a primary key as a picture. Here, if you see, I have category ID, which has a duplicate value, category name, subcategory description, and item description. So item ID alone doesn't have a duplicate key. I have mentioned it as a primary key in here. So the column which is having a primary key doesn't allow you to have a duplicate value, and it will not allow you to have a null value. What is null? Null Null value is you cannot define a null.
Zero.
Right, null is an unknown value. You cannot have null value under a primary key column. So a column based on this primary key in a table, you can able to uniquely identify a particular record. So when you can able to identify a record uniquely, then that particular column is a primary key column. And what is foreign key?
Foreign key
Foreign
is
key, yeah,
to
The
maintain a
table
relationship between one or more table, more than one table.
yeah. To have relationship between table, you will have the references based in term of a foreign key. A table with a column which is having a foreign key will have duplicates of data in it, where the table with a foreign key is treated as a child table and parent table will have a primary key. When I say a table is having a primary key and a foreign key, I mean, and another table is having a foreign key, which table data will be inserted first?
Parent will be inserted first.
and
Yes, that parent should exist first and then child should be there. You cannot do a vice versa case. So once parent records are inserted, and then you can go ahead and insert the child table. In case of fact table definition, I've given a word that a fact is a quantitative piece of information which is stored in fact table and have foreign key relationship with the number of dimension table. So when they have foreign key relationship, which means fact table will have foreign keys. Dimension table will have primary keys. So when I have set of fact table, set of dimension table and a fact table, which table will get loaded first? I repeat, dimension
fact
table will have primary keys, fact table will have foreign key. The foreign key in a fact table will be referred to the primary key in a dimension table. Which
fact
table data is inserted first, fact or dimension?
fact table
Why fact table?
because it is unique.
No, I'm asking, fact table will have foreign key fields. Dimension table will have primary key fields. So which is parent table, which is child table here?
Dimension is a parent table. Fact would be
Parent table, yes.
child.
Correct. In that case, Srikanth, now tell me which table will be loaded first?
Fact table.
No, 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 no.
Fact
Obviously,
table
dimension.
has foreign key. Foreign key, the table which holds foreign key is considered as a child table. A table which has a primary key is
Okay.
considered as a parent table. See, only if a
Parent table.
parent exists, the child will exist, right? So in that case, dimension
Yes.
tables will be loaded first and then the fact table. Can able to follow, Srikanth?
Okay. Yes, yes, yes.
Right, it's not a reverse case. So you will have a set of dimension tables with the primary key values, and you will have a fact table with the foreign key values. So when I say which table is loaded first, it is always your dimension table because it holds primary key in it. This is one of the important interview question in case of data warehousing concepts. You have set of for a fact table and the dimension table. Which table gets loaded first? Your order of loading when you are proceeding with a batch is the first dimension tables will be loaded and then the foreign key gets
Because
loaded.
it is the parent one.
Exactly.
Yes, yes,
Exactly. Okay.
yes.
Yeah. So dimension table is also called as a reference table, and the dimension table contains, it can have a surrogate key or a natural keys in it, right? Okay, now we are into this topic, like what is a primary key? A primary key will allow you to uniquely identify a row in a table. It will not have duplicate value, it will not have the null value in it. Foreign key, foreign key will have duplicates. It will have it is actually a child table which will be referred to a parent table. It is which is a table which is having a primary key. It will be referred to it. You will have a relationship between tables based on primary key and foreign key. So there are some cardinality types, like how the data is getting related between the tables. The relationship may be of different types, like one-to-one means one table joined to other table. One-to-n, one table can be joined to multiple tables. Many to many, many tables joining to many tables. So we'll see all those in later sessions. Okay, these are all very basic concepts of relational RDBMS, but just giving a overlayout because we need those things in the database. Right. So you know what is fact and what is dimension. Now we'll see types of facts. So when I say types of facts, facts are numerics which are measurable. There are different types of facts. They are additive fact, semi-additive, and non-additive. Three different types of facts exist: additive, semi-additive, and non-additive. So additive facts are facts that can be summed up through all the dimensions in the fact table. That can be summed up through all the dimensions in the fact table. For example, I have store ID, product ID, transaction date, and revenue. Store ID, yes, I do have a repeated value S1, S2, S3. I have three store IDs here. Product key, I have P1, P2, and P3. Three product keys here, and transaction dates, three dates are available here, and revenue. So here, out of these four columns, which column is dimension and which column is a fact? Can you explain? Now you know what is fact and what is dimension. Just tell me whether store ID is a dimension or a fact. Store ID column is a dimension or a fact.
Store ID is
Dimension,
Dimension. Why it is dimension?
because it is giving the description of
Product key.
the product. Yes,
Product key is fact or dimension? Shrikant?
dimension.
Dimension. Transaction
Yes,
date.
dimension. And revenue is fact.
Dimension. Revenue, yes, revenue. Revenue is fact. Why
Is
it is
fact.
fact? You can
Yes,
able to measure it, and it is also
measure.
numeric.
We can
Numeric which can be measured. I can measure how
measure
much
this.
revenue generated based on what. Can you able to measure how
Based on the
much revenue generated based on the store? Can you able to analyze it or not?
yes, yes,
How much revenue generated based on the product P2? Possible or not?
possible.
possible.
Possible. How much revenue generated on 28th August 2010? Possible or not?
Possible.
Right? So dimensions are
Yes,
used to analyze the facts. Now I hope you can understand with this example. Now coming to
yes.
additive fact. Additive facts are facts that can be summed up through all the dimensions in the fact table. Now what are all the different dimensions in this table? Store dimension, product dimension, and there is a transaction. Now you can able to sum up. When I say sum up, it is not only summing up, like whatever aggregate functions are there, everything it is applicable. Any one is applicable on it. What are the aggregate functions? Sum of, max of, min of, average of. So these are some of the aggregate functions. Now store wise, I want to analyze the revenue. When you see the bottom sample below the table, actually, okay, S1, S2, S3. What I have done here, I
We have
have
categorized.
repeated store keys. I have taken S1, S2, and S3. I took the grouping
Store
of the store key. So when I group S1, how many S1 is there in the table? 1, 2 and 3. There are 3 times you can see S1, and all those 3 records of S1 revenue you need to sum up. I just gave an example of summed up value. For example, S1 in the first record is 100, S1 in the fourth record is 600, which means 700, and S1 in the next record is 200, 800, 900. So S1 is a store key. I just grouped it and checking the sum of revenue. Sum of revenue is what? 900 here in the sample. Similarly, S2 store ID wise, what is the sum of revenue generated? 550. S3 store, what is the sum of revenue generated? 700. It is the fact which can be summed up through all the dimensions. Store is one of a dimension where I can able to do the sum up. Similarly, product P1 wise, what is the sum generated, sum of revenue generated? P2, P3. Date wise, how much revenue generated? So each and every dimension is allowing you to apply the group functions and the aggregate functions on the fact table. So when all the dimensions in the fact table allows you to do a sum up value, then it is called additive fact. Can you able to understand?
Yes, yes, ma'am.
It is not only the summation of value. It can be average, it can be min, whatever it can be. Clear? This about, give me a second.
This conference will now be recorded.
Yeah, I'm sorry. Yeah. So here, uh, the dimension table, which can be summed up with all the dimensions on a particular fact, is nothing but an additive fact. Now we'll move on to the next type of fact, which is semi-additive fact. Semi-additive facts are facts that can be summed up for some of the dimensions in a fact table, but not the other. That is, with some dimensions you can able to analyze it, you can able to sum up the dimension, but not with all the fields. See, there is an example here: account ID, transaction date, and current balance, where a profit margin is provided. Here, in the above table, we cannot sum up the current balance across account ID. So when I say current, what is the current balance of 1, 2, 3, 4? I do have 2 records in the account ID 1, 2, 3, 4. When it is called as a current balance, what is a current balance actually? Whatever you hold in your account right now is a current balance. Am I right? See, on
Yes, yes,
18th April,
correct.
it was 5,000. On 19th April, it is 3,000. You cannot provide a sum up value of the account ID to say 8,000 is the current balance. That is not right. Yesterday it was 5,000 and today you hold only 3,000 rupees. So current balance is only 3,000, where you cannot do a sum up of value here. That is, you can't apply the aggregate functions on this particular dimension. Clear? Similarly, transaction date. On this date, you did a transaction of this. On this date, you did a transaction of this. You cannot sum up. Each day transaction is different. The current balance is different. Profit margin. Profit. With this particular account ID, on this date, profit is 0.05. On the another day, the same account ID holds a profit of 0.03. Can you able to sum up the profit margin of a account ID? How much profit generated by this account? Yes,
We
you
can
may
do
need to
it.
sum up.
Yes, we can do it.
Sum up. Say 0.05 plus 0.03 is the actual profit of this particular account ID, which means what? It is allowing you to sum up certain fact fields, but it is not allowing you to sum up some of the fields. So semi-additive facts are facts that can be summed up for some of the dimensions in the fact table, but not the others. Is it clear?
Yes.
Yes.
Only with few you can do the sum up, but not with all. That is, as the name indicates, semi-additive. Partially you can and partially you cannot. Semi-additive. The next sample is a non-additive fact. So non-additive, as the name indicates, non-additive facts are facts that cannot be summed up for any of the dimensions present in the fact table. Facts which have percentage or ratio calculations cannot be summed up. In real time, mostly this will not happen. In rare scenarios, like when you have a percentage and the ratio calculations, you will have the non-additive facts. Most probably you will have additive and semi-additive facts. Here, there are three types of facts: additive, semi-additive, and non-additive. Additive facts, which allows you to sum up with all the dimensions in it. Semi-additive, which allows you to sum up only with few of the dimensions. Non-additive are facts that cannot be summed up. See, the definition says as summed up, which is nothing but an aggregate. You can able to perform aggregate functions based on all the dimensions. On some of the dimensions, you cannot perform the aggregate on any of the dimension. That is non-additive. Clear? Any doubt?
Yes. Yes. No.
These are types of facts. So what is a fact table? When we are moving to the next topic, fact table. A fact table will have facts. Facts are nothing but measures of a business process, and it contains a foreign key to the dimension table. We already discussed this just before. Fact table will have facts of the business process, and it contains the foreign key to the dimension table. Then what is a dimension table? Dimension table contains dimensions of facts which adds meaning to measure and facts. See, without having a dimension, you cannot analyze the fact. So dimension tables adds meaning to the facts. They are joined to the fact table via foreign keys. Dimension tables are denormalized tables. So there's a concept called normalization in database. So what is normalization? Normalization is a process to reduce data
Cleaning the
redundancy.
data.
Right. What is redundancy?
All duplicates we have to clear.
Yes. The record, which is the table, if it is having a repetitive value, is nothing but a redundant record. Redundancy, instead of saying it as a duplicate, the term which will enhance your technical stuff is nothing but redundant data. I do have redundancy in the table, which means I do have duplication on the table. So if you want to minimize the duplications, then you will go for a normalization process. So normalization is a process where you can reduce the data redundancy by splitting the tables into n parts. I have one particular table which has lot of data duplication redundancies. And if I want to minimize the data redundancy, I should split the table into n parts. We will see the normalization concept as an overlayout in further topics. So here normalization is a process to remove data redundancy. So when it is called denormalized table, those are nothing but the table which will hold redundancy. It will have data redundancy. So always remember, dimension tables are denormalized table. This is also an interview question. Whether dimension tables are normalized or denormalized. Your answer should be it is a denormalized table. Yes, it will have data redundancy. There are cases where your dimension table can be normalized, but that is based on the requirement of the schema whichever you are going to define. In general, dimension tables are denormalized tables by default. Each dimension will have various attributes. If I say customer dimension, customer ID, customer name, customer age, all this. Account is a dimension table: account ID, account name, account type, account holder some status. So all these comes under account table. So dimension is nothing but consider a table. A table has multiple columns, and those columns which are used to analyze a fact are nothing but dimension table. Fact table contains foreign keys. In that case, dimension table will have primary keys. Clear? See, whatever topic we are seeing today are very important terms that is used in data warehousing. You should know what is dimension, what is a fact, what are the types of dimensions, sorry, types of facts, what is a fact table, and what is a dimension table. These things that we have seen now. Also, we just had a brush up of primary key, foreign key. We forgot to discuss one of the key called surrogate key. What is a surrogate key? Any idea what is surrogate key?
No idea.
Idea. So surrogate key is also used to uniquely identify a record, but it
Am I
is not
audible?
a business column. It is not a business column. That is, see, these are the columns of this particular table, which is given from the source system or from the source where whatever you have those data. Assume the column item ID I don't have in it. Okay, just assume that the 1, 2, 3, 4, fifth column item ID is not available, but still I want to bring uniqueness in the table. Without having a item ID column, if you see category ID having duplicates, category name duplicated, subcategory ID duplicated, category description duplicated, item description, yes, duplicated. Or else, since it is having an item key as a primary key, it doesn't have a duplicates, but there are possibilities. Assume in that case, if I have a duplicates in the table, but still I want to maintain a uniqueness, in that case you are manually going to generate a new column which will have a sequence of numbers. Most probably surrogate key is a sequence of number. When I say sequence of number, it is 1, 2, 3, 4. So how many records are there? Those many numbers will be inserted in it. The column which you are forcibly adding to it in order to bring data uniqueness under each of the record is nothing but a surrogate key. So surrogate key is not a business column. It is a technical field which is introduced to uniquely identify a record. Clear? So you are introducing a new field on yourself to have a sequence of number. See, if I have, see here, if suppose I have 10 to 12 records, 1, 2, 3, 4, 5 sequence number, I'm adding a column, I'm generating a unique value. Then can you able to identify a record? Yes, fifth column, fifth row, I can able to identify. Seventh row, uniquely you can able to identify a record based on a surrogate key. Clear? It is a field that you are introducing at your end. It is surrogate key. Okay. So you know dimension table, we'll see with an example here. The objects of the subject are called dimension table. Dimensions. The objects of the subjects are called dimension. So this is which subject now? Customer, product, date. See, subject is e-commerce. E-commerce is a subject here. Sales, you can say it is a sales domain. Under sales domain, under e-commerce company, you need to maintain a data. So you will maintain a data of a customer, of a product, of a date. So these are nothing but dimensions. The table that describes the dimensions are dimension tables. Dividing a data warehouse projects into dimensions provides structured information for reporting purpose. Now under customer, I have customer ID, customer name, contact address. Under product, I have product ID, product name, product description, price. Date, I have some delivery date, shipment date, order date. So these are nothing but what? Attributes. Attributes are nothing but a column. Table name are nothing but dimensions. And all these tables belongs to which subject is e-commerce here. Is it clear?
Yes.
It's a very important and interesting topic in data warehousing concepts. So what are the different schemas available in data warehousing? There are two schemas available. One is star schema and another is snowflake schema. Snowflake. Star schema is actually a larger topic. We'll go in depth actually. The first schema type is star schema. This is star schema. Star schema consists of one or more fact tables referencing any number of dimension tables. Which means what? It can have one or more fact table referencing to multiple dimension table. Star schema is the simplest style of data mart schema, and this approach is most widely used to develop data warehouse and dimension data mart. So dimension tables will contain dimensions that are used to analyze the fact. Facts fact table, a centralized fact table surrounded by one or more than one dimension table. Right? See here, see the diagram here. I have one fact table surrounded by four different dimension tables. What are the dimension tables? Product, employee, time, and customer. So these are different dimension tables. They are linked to one fact table. So fact table will contain what?
Unique one.
Fact table will contain facts. Fact table will
Only
contain
unique.
facts. And
Summarized
also
data.
it will have foreign keys. It will have foreign keys. Dimension table will have what? Dimension table will have
Description.
multiple
All the description
descriptive
of the.
details of the dimensions with a primary key.
Yes.
A
Yes.
foreign key in a fact table will reference to the primary key of the dimension table, right? See, if you see this diagram, it looks like a star. Star, a central dot with various sparks in it. Like you have surrounded by multiple dimension tables, centralized fact table. Since the design looks like a star, it got the name star schema. All these dimensions, which we have already seen, dimension tables are denormalized dimension. Fact tables surrounded by dimension tables may have data integrity and storage issue, which means when I have multiple joins, so now you are joining all these tables, right? More number of joins always degrades the performance, right? But here it is not. See, when I say data integration storage space, why it comes here storage space? Because this is a denormalized table. When it is denormalized table, what it will have? Each table will have
It will contain all the
data
duplicates.
redundancy.
All the.
Yeah,
Yes. Yes.
it will have too much of data duplications. Yes, but with
So the
duplications
storage
we
will
can
be
able
high.
to, yeah. So what happens here? The storage space, it will hit unnecessary data you are holding. Yesterday, some 500 records we received. Out of 500, maybe 200 records are repeated for tomorrow's load. The same records we are receiving even tomorrow, and the same record we are repeating on daily basis. So what happens here? Unnecessary data storage is happening, which will have a storage issue. So we do have some mechanisms to avoid those redundancies, which we'll see later. So as of now, what is star schema? Star schema is a centrally located fact table surrounded by various dimension tables. Dimension tables are denormalized in structure. Fact table will have foreign keys and facts in it. Foreign key of a fact table will be referred to a primary key of the dimension table. As this design look like a star, it is called star schema. Right? We'll see a sample here. Now, with detailed fields we are going to see here. I have fact table, I have dimension table. Let's see dimension table. Product vendor is a dimension table which has product ID, product name, model name, etc. etc. So many fields. Employee, all the fields under employee, time ID, and customer, all these tables. Now, to avoid duplicate, to uniquely identify a record in a table, they have already provided primary keys for some of the fields. You can, okay, product. Each of the dimension table are having a primary key. You do have a fact table at the center where you have foreign key, that is a time ID, primary key in time dimension. It is a foreign key in a fact table. Customer ID is primary key in customer dimension. It belongs to a foreign key in a fact table. Product ID foreign key in fact table. Employee ID again a foreign fact table. Okay, foreign keys. Apart from the foreign key values, you have amount and quantity. What is an amount and what is a quantity here? What are these amount and quantity field? Just think, what is amount field?
Amount
It is
field is
measurable.
it's a fact, right?
It's a fact.
It is
So
measurable.
amount, yes, amount, quantity, both are numerics, both can be measured and both will have impact on the business. These are nothing but a measures. These are nothing but a fact. So based on these dimensions, you are going to analyze these two fact. What is the amount of profit on this particular month in this particular year? Yes, you can able to identify how much
Yeah.
quantity sold with this customer on this product
For this
with a
employee.
particular duration of time. Like however you want, you can interrelate and analyze the data. With this employee, this much of quantity sold on this particular duration with this particular product, right? So whichever way you want, you can able to analyze the data based on the dimension tables in it. Can able to follow?
Yep. Yeah.
In this
Yes.
country, on this particular state, in this city, only this much amount got generated as a profit. But the other country, other state or other city is having more profit than this particular product.
Okay.
Okay, so you can able to analyze it. Clear?
Yeah.
Yes. Yes.
So this about the star schema. It will have centralized fact tables surrounded by multiple dimension tables in it. Clear?